I'll be your host, Jamie Larson, along with Brett Dojan. Hopefully, you're both familiar with the two of us by now, and the extra perceptive ones among you might notice I have a new title of Regional Sales Manager. I was promoted back in November to take over the Western region, currently held by Chuck Engelbrecht. He will be retiring on May 1st, so I'll be traveling with him on this call. Hopefully, I've met some of you already, but enough about me. Today's Power Hour is going to be a refresher course on log and accumulator data values.
Okay. Now that I have you, I trust, it looks like you guys see the scaling basic information slide. This is where Jamie left off. Previously, really, he just gave an intro to the agenda where basically it's going to be slides talking about scaling, followed by a demonstration by myself. And I'm going to throw in just kind of a bonus thing at the end. Really, just take about 5 minutes before we wrap it up. So I'm going to go ahead and get started. As far as scaling, really, what is it? And really, as it pertains to the Orion, what is the usefulness of it? And to answer that question, first, we have to really, to say, what is the use of the Orion? What is it used for? And in its most common application, we use the Orion as both what people in the industry call an RTU and also as a data concentrator. And that means that the Orion pulls data from various external devices. But it's worth noting that those devices are by various manufacturers, and those, the communication happens using various communication protocols. The fact is just there are all sorts of devices out there, different manufacturers, and they all do it differently. But all that information, all that data gets collected by the Orion, and that data then gets sent to a head-end unit, whatever you call it. In our industry, a lot of times we may refer to it as a SCADA master. And just know that if I refer to a SCADA master in the rest of the presentation, that's what I'm referring to. Now, some utilities on this call, we have some customers that really just use the Orion as their SCADA solution. We just refer to it as Orion SCADA. And in that case, that SCADA master unit is also an Orion. So what I'm talking about here, of course, would apply not only to the RTU data concentrator type Orions, but also the SCADA master Orion. But I say all this just to make the point that the head-end unit, the SCADA master, it collects data from all over your system, and the expectation of that is that data is going to be consistent in format. And we'll get into, and that's what scaling is all about, to manipulate data so that it's consistent in the way it's presented. Now, the problem that comes with communicating with different devices and from different manufacturers on different protocols is the fact that the data gets reported in different ways. And I've included a few examples here. For example, one device might record just an integer value reporting voltage in volts. Now, another device may report the voltage instead in kV, where it'll be probably a whole number with a decimal or something like that, stating the number of kvolts. You might have a phase angle, and a phase angle could be quite simply a signed integer value. So signed meaning it can be a positive or negative value, where it's just between 180 and positive 80, where of course every number is a different degree in the phase angle, which is something that makes perfect sense. Now, other devices go for a little bit more precision. While they still report it as an integer value, you might have a value like I show on the right, a value between 1,440 and 1,400 or 1,440 is what that slide should say. But what they're saying is just one integer count is equal to an eighth of a degree, or 0.125 degrees. And this is just in the case where the device is not able to or chooses not to report values in decimal, which would be called a floating point value, but instead it uses an integer value and there's a multiplier involved, and we'll get into that in a second. That's what we call a scale factor. Then you might have another example here. This is just where you might have power factor, and most people know power factor is maybe a percentage. And if you have it between minus 100 and 100, where that would be like a percent power factor, or you see it stated as a decimal between minus 1 and 1 also. You can have it stated like that, where 1 counts just 0.01. But I've seen in one case before, sometimes maybe you have a power factor with an integer that's between 0 and 200, where it makes an unsigned value where, just based on that, say 0 represents minus 1 and 200 represents 1. So then you would end up having a positive integer value that you then end up having to kind of shift that value. So that, to make half of those values negative between 0 and 100. But really, there are all sorts of examples. That power factor is kind of a special case. But the Orion does support floating point values. But one thing we have to note is that not all manufacturers do support that in their protocols. So kind of as I said, for either for the sake of compatibility or really just because the device doesn't support it, a lot of device manufacturers will send their SCADA points as an integer value. And if you look through their documentation, they will include a scale factor with it. The scale factor is nothing more than a multiplier. So for the integer value that it sends out, you would multiply that value by the scale factor, and you would get, I guess, what the true value or that true measurement, what that is. Anyway, the use of a scale factor, as you kind of see, when I was talking about the example of the phase angle, it allows a more precise value or more precise measurement in the value, while the data is also able to be reported as an integer. So to give you an example of scale factor, here's a fairly simple example. So most manufacturers provide the information in their documentation, as I said, which includes a scale factor, or really what to multiply that integer value by. I had mentioned that on the previous slide. So here's an example where, let's say you have the frequency on a device is measured at 59.975 hertz. Now, in their documentation, they say that they have a scale factor of 0.005. Now, based on that information, it's easy to calculate what the integer value will be that is sent through their communication protocol. Let's say that's reported to a SCADA RTU by simply, and I had mentioned the inverse of this on the other page, but if you have a measurement, in this case 59.975, you can divide by that scale factor to get the value that'll be reported across the protocol to your RTU. And you'll see right here, I divided the 59.975, I divided it by that scale factor, 0.005, and I came up with a value of 11,995. Now that is the value that you will see on your RTU. And as you see, that's the value reported to the Orion. Let's see. Jamie, are you on the call? Are you, how's your microphone? Do you know if you had a chance to test it? If not, I may just go ahead and take over. Just keep going with it. Okay.
So I was able to select a different default microphone. I'm not sure if I'm coming through any clearer.
Yeah, as of right now, you are.
As of right now, it's good. Okay. I'll just let you work the slideshow, and I can just let you know when we need to move to the next slide.
Yeah, of course.
Sure. Is this new slide, this one you were just doing? I was working on my microphones.
That's right. Hey, let me do this slide to kind of finish up the example, and I'll let you take over. All right. So the inverse of this, and this is what I had mentioned 2 slides ago, where you now it's worth noting the scale factor is also what you might consider to be the precision of the measurement that comes across through SCADA. So if that frequency scale factor is 0.005, well, that's also the precision of that measurement, because since each one, each one integer represents 0.005, the measurement that's getting sent across just by that fact has a precision. You can have precision of that data down to 0.005 hertz. And to convert that value, so now you have the value that was reported through SCADA, to convert that back to that actual measurement that is in hertz, you just multiply that value through SCADA, that 11,995, multiply it by the scale factor, and you will come up with the true value in hertz. So why do I say this? Of course, it's very relevant to your data, your data that you record and you store and archive by your SCADA master. But again, since different devices send this data across in a different way, and maybe there's a different scale factor, maybe they send that data in a different way, somewhere there would need to be an adjustment made so that all these different devices that are sending data, the values are all collected and they are similar in format. Like, let's say they're all, as far as this example, they are all measurements, relative to, like, in the neighborhood of 60 hertz. So somewhere you have to make an adjustment there. The substation RTU would be a fairly common place to do that, but in a lot of cases, the SCADA master might bring in the data and it might make the adjustments itself within the SCADA master before that data gets archived. We're probably going to go through the rest of this presentation under the assumption that, here's how you make this scaling adjustment in the RTU. Though, keep in mind, and especially for our Orion SCADA users, you can make these adjustments really just by doing the same thing I'm showing you. You can do that on the Orion SCADA master too. Okay. Jamie, how are you? You ready?
Yep, I'm good. So Brett kind of showed a pretty simple example of the type of math that has to be performed on incoming data points to an RTU. But in an RTU, specifically in Orion, where is that math actually performed in a configuration? The two places would be typically the client port and the server port. They're controlled by the min and max fields for all of the inputs and outputs, which hopefully you're familiar with where those are at in NCD, but Brett will walk you through those. One thing to note, typically you're not going to do any scaling on a client port, because when a data point comes into the Orion database is only storing a normalized value, or what we call a percent to full scale. It's more typical that the adjustments you're going to make in the scaling will be on the server port heading up to your master SCADA unit. Right, you're okay. So along with server ports going to your SCADA master, you're also going to be sending these input points from IEDs to other modules within NCD, such as Logic or to your HMI screens. So the scaling can be performed either on that server port to a master or on a server port to another module within NCD. Go ahead, Brett. So how scaling works in the Orion, we're going to go over some theory and some equations here. The definitions that you need to be familiar with, value from the end device. In our example, the frequency earlier, that's the 11,995 integer. Percent of range. I mentioned that the database in the Orion stores a percentage that represents the position of the current value from that end device relative to the minimum and maximum scaling on that client port. And then the last definition would be the value that's actually sent to the SCADA master. And we'll go step by step through all three of those, give you a better understanding of what's happening to the data values as it passes from an IED all the way up to a SCADA master. So our goal here is to calculate correct minimum and maximum values on the server point, in the server protocol for a specific point. So the first thing you need to determine is what is the relationship between the value that you're receiving from your end device and what is your SCADA master looking for, whether that be signed, unsigned, integer. So if the value from the end device is already what the SCADA master is looking for, including units such as voltage, kilovolts, then you don't have to change anything. And NCD is built such that the minimum and maximum scaling on the client port and the server port will match. So if the measured value is what SCADA is looking for, no need to change anything. So that's the first item you need to determine. If you do need to adjust the scaling, then continue on to step 2. In the frequency example we talked about earlier, we're going to assume that the SCADA master wants to see the real frequency value to 3 decimal places. And the SCADA master protocol does support floating point values. And we already determined that device that's measuring frequency will only transmit an integer to the RTU. So we'll step through some equations here to show you how you can get that measured value all the way up to the SCADA master. Couple simple equations here, no need to be freaked out. These are all posted in a tech note that's built into your NCD documents folder. It's pretty simple math. So this step 2 here, this is kind of an intermediate step where we calculate the percent to full scale value that the Orion database is storing, so that later we can check our work and make sure that the min and max scaling we put on the server port is actually giving us the value correctly and how we want to see it. So to determine the percent range, you're going to take whatever value is being inputted from your IED, subtract the minimum range, and divide by the maximum minus the minimum. So in the frequency example, the integer coming in is 11,995. And we were on a scale of 32,768 to 32,767. So performing that simple mathematical calculation, that 11,995 on a scale from negative 32,768 to 32,767, we're about 68.3% to full scale. So we'll take that number and hold on to that. To adjust the minimum maximum values for the scaling on the server protocol, it's an even simpler calculation. You're going to multiply the minimum and maximum values in the server port by that scale factor, which was 0.005. So if we take the scales that are already populated in there for a minimum and maximum, 32,768, 32,767, multiply those out by the scale factor, you'll get these negative 163.84 and positive 163.835. So those are going to be your new min and max values in your server port for that data point. And if you want to check your work to see what value is actually being sent to the SCADA master based on that scaling, simple equation, maximum scale minus minimum scale times your percent full range plus the minimum value. And working out that math, you can see that we've got the 59.975. So we went from a device measuring 59.975 hertz, which then sent an integer value of 11,995 to the Orion. The Orion converts that to a percent to full scale value. And then with the scaling on the server port, it then back calculates this 59.975 hertz. So kind of in summary, some general scaling tips and guidelines. Again, if no change is needed, minimum, maximum values can be left as is. Changing from volts to kilovolts, again, in the server port, if you move the decimal point either left or right. That's a really easy way to scale from volts to kilovolts or whatever decimal movement you need. It's also a good way to preserve the decimal portion of a data value. So if you've got a client device that doesn't support floating points, on the client side, you can simply bump that decimal place over. It'll report a full integer value. And then on the server side, you can move the decimal place back to get that floating point all the way through from your IED to your SCADA master. If you need to change the scaling factor by any other factor, multiply server protocol minimum maximum values by that number. That was kind of the end result of the math that we just did, multiplying by a scale factor. And what we covered here today should satisfy about 99% of all of your scaling needs you might come across. I mentioned it before, but we do have a tech note on scaling that's in our NCD documents folder. It's got even more examples, some extra diagrams. So if you're having any questions, take a look at that. Again, I apologize for the technical difficulties here. That's not how I wanted to end my Power Hour career, but thanks for bearing with us, and I'll pass it off to Brett for some demonstrations now.
Yeah, I'll go ahead and take over now. Okay, so now we're moving into the demo portion of this webinar. And we're going to talk about, or I'm going to show you an example of capturing data and using scaling for some analog values that we're bringing in. That's going to be the main kind of showing of the visual to what we've seen in these slides. In addition to that, I'll show you how to present the analog data on an HMI screen. And I'll dive into that right now, but we'll conclude with showing just a logic example in LogicPak that I'll go into detail on that when the time comes. So now to get started with that, I will jump into NCD. And you'll see in NCD, I actually have created a file already, and I've just given it the generic name for this webinar. I'm just calling it Power Hour. The first thing I'm going to do is I'm going to go configure a port. And I will say, I do see we have some really good questions for this webinar. If you have questions, just make sure to submit them. The GoToWebinar interface has a questions section where you can submit questions. I know some of you have already. Please use that to communicate with us, and as we see those come in, we will be answering them in the application. If a question comes up that we would like to discuss directly, I will take time, during the course of the rest of this webinar to talk about it. There was a question that came in pertaining to rounding, and that is one that as I get in to showing scaling here, I'll make sure to make a note to answer that question. But thank you for that question, and I will address it here momentarily. First thing I'm going to do is I'm going to set up a DNP3 client. And everything I have set up in my lab here is set up with Ethernet cables. Everything's a network connection. For our purposes, that's not going to make a really big difference. But we're going to set up a DNP client, and as it happens, we're going to be communicating with a Bitronics meter. So I'm going to type in some information pertaining to that meter. I'm going to punch in the IP address. It defaults to port 2000 for DNP. Client address is 100, and that's just fine. I will add a new device. I will give it the name, just really applying to the meter. I'll call it M650. And it's going to be Bitronics. M650 Advanced is the default that I'm going to select. Now, I'm not going to spend a whole lot of time going through the settings here. Of course, this isn't a DNP webinar, though on our customer community, we do have webinars on a whole bunch of topics, DNP included. Now, if I go to inputs, this is the kind of pre-populated list that is the default point list from the Bitronics meter. I'm going to work with just a couple of these points when we get later on to talking about scaling. But for now, I'm just going to select them all and bring them over. And I'm going to leave all the values here alone. So you'll see now we've set up one device, DNP client. But now that we've done that, let's go ahead and save the file. And I'm going to jump into the web browser here. To set the stage, this is an Orion SX, and it's going to be pulling that meter. So I'm going to click Select Files now, and there are multiple ways to do this, right? You can either drag the files into the screen. I've recently found that I prefer clicking the Select Files button, and it goes straight into where I keep my NCD files, and I sort it by the date modified. So at the top should always be the files that I was just working with. So I'm going to open this file here. I'm going to select it from the list to activate it. And as it does this quick restart here, I'm going to go to data values. I just want to see what two particular points look like, how they're presented. So I'm going to go into DNP client. And there are 2 points in here that are very easy to understand. They're my 2 favorite points in these meters, given my Bitronics meter is not hooked up to an actual system, right? But it does have the AC power going into it. We have volts A to N bus 1, and you'll see the value there. And then we also have the frequency is reporting is 5998. I pick these, one, because they're relevant pieces of data, but 2, also because you can tell it's pretty clear what these values should be. If volts are reporting is 1,239 through SCADA, you know that it's in actuality it's 124.1 volts. And down here you can be certain that the frequency is actually 59.99. So we know what these values are supposed to be, and we see how they've come across SCADA as integer values. And you can see now that making these the values they're supposed to be, the true engineering values, it's just a matter of moving the decimal point. So knowing that, I'm going to go back over into NCD. And actually, I'll jump over here real quick, and I'm going to tell you what we want to do with these points. So let's say when we go to bring these, we go to push them to a SCADA master. The SCADA master wants to see this volts as an actual value, not in volts, but it wants to see the value to make things complicated here. But I'll walk you through it on a 7200 volt base, but it wants to see it in kV. So it wants to see it, a value fairly close to 7.2 kV. And for the frequency, we're going to keep the frequency simple. The SCADA master just wants to see a frequency that's on the order of 60 hertz, 60 point, and we'll say we want 2 decimal places on those frequency in hertz. So now we'll go over to NCD and we'll make that happen. So we're going to set up a connection to SCADA master. We're going to do it with DNP. So we're going to set up a DNP server. And now it's worth mentioning something here. I'm going to go ahead and add an RTU. My plan, what I'm doing here, my assumption is that the SCADA master will support floating point values. Floating point, most of you I think know, but for those who don't, a floating point value here is kind of as opposed to an integer value, where an integer is always a whole number, so there's no decimal component to it. The floating point type of value always pretty much is what it is because it has a decimal, like a below zero component to it, and we'll be able to send the decimal point over. We'll be able to send the places that are less than 1. So we'll be able to send the value, for example, of 59.98. We'll be able to send that over via floating point. Now, if we're working with DNP and we're sending values to SCADA with DNP, you'll need to look at this down here. By default, the Orion will send all the data in its DNP server. It will send it as 16-bit analogs. But if we want to send something that has a decimal component, we cannot use this. What ends up happening, and this starts to address the question we'd received regarding rounding. If we have, for example, let's say we have our frequency value that is 59.99. If we want to send this as a 16-bit analog, again, as an integer value, the way the DNP server, the way DNP handles that is it's going to try to send an integer. But what ends up happening is it ends up chopping off, just disregarding the decimal portion of that. And it rounds. It takes that decimal component and it rounds to the nearest whole number. So when we set this up, if we would set this up and send it as a 16-bit analog, the value we would end up sending is 60, which, if we're talking about frequency and we're sending over a whole number of 60, clearly that's not the precision that we're looking for, right? Because, the frequency is going to almost always be around 60. It's, I think, just kind of intuitively, we want a decimal component on hertz. In DNP, you'll go to right here under port where it says object 30 analog, and we're going to want to select one of these floating point options. Now, I'm going to choose the shorter option, and this is a fairly small number, short floating point, and I'll click accept right there. For those of you using other protocols, I will say in the case, now you're probably not going to send data to a SCADA master using SEL protocol, but if you're getting data via SEL protocol from one of your devices, if you're polling a Schweitzer device, that data, that by nature supports floating values. The Schweitzer device will send floating values over. The SEL protocol will support that 100%. If you're using Modbus, you can select, when you're configuring each point, you can set each point as an integer or various sizes of integer or floating point. So just so you know that. Now, in the case of this DNP server, you have to select that, and your SCADA master, you have to know also that SCADA master will support receiving floating point values, because some do not. We're assuming in this example that it does. So that is step one. If I go now to inputs, I'm going to bring these values over, volt A, and I'm going to bring frequency over also. But this is where we need to determine our scaling. And I put together, guys, this is not a template. I guess I would say you don't ask for it. It's not really something, there's nothing magical here, but I put kind of a table together that's going to help us determine the scaling. So for volts right here, we have 12, we'll say 1246, and here we have 6002. 1246, 6002. I'm going to lead you through a process here that's going to help us determine the scaling factor, and it's going to allow us to resize the min and the max for the purposes of scaling. So remember what we wanted here. With the volts, we wanted kV. We wanted a value in kV. The first thing we're going to do is we're going to bring it to a 120 volt base. The way we're going to do that, and there's no formula here, I'm just going to say divide by 10. I divide by 10, I'm going to get 124.6. Hope you're with me so far. Now, anybody who has a distribution line of 7200 volts, I think pretty much knows by heart, for rapid recall, that the ratio there of the 120 to 7200 is 60. So we're going to multiply that value by 60. Now, here's math I can't do in my head, but we're going to take the 124.6. We're going to multiply it by 60. That's actually not going to work. Let's multiply it just by the number 60. And we have 7476, which that sounds right as a value on a 7200 volt base. So now the last step of this process is that we were told to express it in kV. So, excuse me. Sorry about that. We're going to divide. We're going to divide by 1,000 here. And what we're going to end up with is 7.476. Keyboard's acting up right now. Okay, so now to determine the scaling factor, basically it's just going to be combining all these actions together. So we're going to say it's 1/10. We're going to times it by 60. And we're going to take that and we're going to divide that by 1,000. So now we have a scaling factor of 0.006, which is just basically combining these three. So now we're going to take that scaling factor and we are going to multiply the default min and max values. Now, if you work a lot with this, with SCADA, you'll recognize these. These are standard 16-bit signed. This is a signed 16-bit value range. So if I'm calculating new values, I'm going to multiply the min. I'm going to multiply that by the scale factor. and I have a new value here. Let's draw this out a little bit so we can see the decimal places. And we're going to do the same thing here. We're going to multiply the max by the scaling factor. Okay, so we have new min and max values right here. We're going to do the same with the frequency, though this is a lot simpler. We just need to get it to near 60 hertz, that 60 hertz base. So we're going to divide by 100. Not difficult, right? 60 60.02. Scaling factor here is pretty easy. It's 1 over 100 or just 0.01. So now when it comes to the new min and max values here, if we're saying it's 0.01, we're really just moving the decimal place. 327.68. Yep. No. Okay. Let's try that again. Minus 327.68. Bring it out so we can see the decimal. And here we have 327.67. Okay. These are the values. These values right here are what we're going to be plugging into our server protocol, just so that scaling, that rescaling of the values can happen. So I'm going to move this off screen, but now we know what we need to replace these with. So for volts, we're plugging in minus 196.608. Max value is going to be 196.602. For frequency, we're just moving the decimal point, right? So I'm going to insert a decimal point here, 2 decimal places, or two digits in, and I'm going to do the same here. Okay. So now we've set that up for DNP server. I'm going to set up the exact same thing, and this will lead into the next portion of this demo. I'm also going to configure an XML server, because we're actually going to make a very simple HMI screen, and I'm going to go into displaying analog data. So we're going to add a new file here. Not much needs to be done really, except we're just going to add those points. We're going to add volts. We're going to add frequency. And these scaling values are going to be identical to the other screen. So 196.608. And this one is 196.602. Add a decimal point here and here. Okay, so now we have an XML protocol. And since I'm adding this, you know that the XML protocol is used for HMI screens. It's used within the Orion. So I should say here that this scaling has applications not only for sending data to a SCADA master, but also using certain modules within the Orion. If we're going to, we can modify the format of the data, I guess, the display of the data for HMI screens. We can also do it really for any of our logic engines. If you need the data to come into the logic in any of those formats. You can do it also if you're going to archive data from this Orion. You can use scaling to change the values that are then going to be archived. That's another note. Yeah, so you can use scaling to prep data to be used inside the Orion also. So now that that's finished, I'm going to go ahead and save the program. And we're going to jump over to the web UI real quick. Again, Orion SX. So now that I've made changes to that file, we'll jump back over here. We will select it from the list and we will send it back with the changes we just made to the Orion. Let's go here to devices just to make sure that the communication is taking place. Again, we're communicating with a Bytronics meter. You'll see it is still communicating. Under data values, we're going to go to DNP server. And you're going to see these are the values as we are sending them to SCADA. 7.48. See, it's in that 7.2 kV base that we were looking for. And the frequency you'll see now is 60.02. Again, that is the way we want it presented. We're going to go back over to data values again. I mean, we can look at the XML. It's going to look exactly the same. It's showing offline, and well, no, it's showing online now, but we don't really have an HMI screen that it's tied to. So now enter Inkscape. I have an Inkscape program open. A very simple, just couldn't be simpler HMI screen that's just going to show voltage and frequency. So you guys can guess what we're going to do here. So I'm going to open up our screen so we can link points to it, and that's under extensions and Novatech HMI. There is also the shortcut if you hold Alt and then you press the / and that's the slash that's tied to the question mark on the keyboard. I'll show you briefly just about how to display the analog values. Let's bring this over here. Okay. So as always, we want to make sure we have the correct NCD file selected. The file, we just called it file 1, so that's going to be good. Since we're setting the voltage, we're going to bring that over as the input point. Now, if you want to display an analog value, you click text display, select decimal, and then you choose the number of decimal places that you want NCD to show, and we're going to select 3. The reason you have to select decimal places here is that Inkscape is going to assume that any numerical value is an integer unless you use this screen to tell it otherwise. And so if the frequency is 60 and you don't specify decimal places, if it's 60.02 like we had, well, if you don't set this, it's just going to show 60. Now, Inkscape, unlike what I said about NCD, I have found that Inkscape does not round the number. So if you have, for example, a frequency of 59.98 and you don't set it to show decimal places, well, then your frequency that shows here, and as I jump from voltage to frequency, in the case of frequency, it's going to round to 59, and it's going to say 59 hertz. Something to bear in mind. You always want to make sure if there's a decimal value on the point that you set that number here. Under text display, you set decimal places to 3. If you want conditional coloring or anything like that, you can go under coloring display, analog, and then there's kind of a logic table you can set up that'll color that analog value based on what that value is. I am not going to do that. I will go ahead and go to none. Save. Okay. Same thing for frequency. I'll do this quickly. There's really nothing new to say here. But now I'm setting the frequency. Text display decimal places 2, and save. Up. Sorry about that. I forgot one critical step. Because we do have to select the point. Decimal places 2. Save. Okay. Now we're going to save that file. We're going to jump back into NCD. We're going to send that SVG file over. So now we're going to see if we did that correctly. We're going to jump into this power hour SVG. Now you may find if you click an SVG file, it's just going to try to open the raw image. It is an image file, but it's not going to be tied to anything. So if you remove most of the path to the folder that the SVG file is in, and you just type in the letters SVG, and the address looks just like this. If I hit enter, now you're going to see the page tied to the points, and you can see now it's displaying exactly the way we told it to. So that's a success. You'll have them displaying just like that. But now let's see. I'm going to jump back over. There is one more thing. As I look through here, there's one more thing I wanted to show you. So again, the DNP server, that's going to SCADA. We had changed the scaling. I had shown how the SCADA, now it's sending floating point values with a decimal component. And as a reminder, you do want to make sure that the device you are sending this data to is equipped to accept the floating point values, that it does support that. The Orion, if you set up an Orion SCADA master with DNP, if I didn't mention this already, it will the Orion as a SCADA master will recognize floating point values being sent. It will recognize that automatically. So there are no settings that you need to set, let's say on DNP client, to tell it to accept floating point values. It will just do it. So that is the main portion of the demo that I wanted to show you. So let me jump back over to the PowerPoint. I'm going to show you one more trick in LogicPak, and I will not, take too much time with this. I'm actually not going to show it in the web interface. I am just going to show you how we did it. So here's what I'm going to show. So this happened last year. A customer had come to us, and they had asked us, we have an analog value, and sometimes this value is going to be 0, sometimes it's going to be a numerical value. But if that data value is 0, this analog value, we actually want to convert it to a binary point with a 0 value. Now, if that analog point is just any value other than 0, we want to make it a binary point with a value of 1. So to do something like this, to use really any of the other logic modules is fairly easy to do. Especially like if you were to use Lua to take an analog value, and basically you're going to say if the analog value is 0, then you do this, otherwise you do this. But LogicPak that's a constraint that makes it a bit more complicated, but I'm going to show you a solution to that. And this is how to take an analog value. If it's going to turn it into a binary point. If the analog value is 0, that binary is set to 0. If not, it's set to a 1. So let's jump back over to NCD. I'm going to show you one more trick in there. This starts with in this DNP client, I'm going to go ahead and add one more analog point. And I'm just going to give it a nice generic name. I'm going to call it analog value. So we're going to take the analog value. I'm just going to consider that the scaling doesn't matter too much here. We're going to go to configure, and we're going to set up LogicPak. So we're going to go to logic inputs, and the tool we're going to use, now all these tools, these different, logic gates, OR and negate, those are designed to use binary values as inputs. So those are not going to work for us. We're going to use the calculator function. So maybe many of you have seen this before, but we're going to set up a new calculator equation. By clicking that calculator icon there, we're going to click add. We're going to call this, just give it an appropriate name. We're going to call it analog to binary. Now, what would we do for a calculation here? And I'm going to tell you, it's probably not something you'd come up with immediately, but it actually involves, I've not found that there's a way to do it without dividing. And if you try to bring in a 0, right, because one of the conditions is the analog value is 0, I was struggling initially to come up with an equation that did not, in one case or another, involve dividing by 0. So I had to find a solution that was able to get around that. So what I'm going to do is I'm going to shoot for getting a value close to 0 or close to 1, and I'm going to have it round. So what do I put in here? I would put, this is what I came up with. I came up with x plus 0.01. I'll explain this in just a moment. Divided by x plus 0.1. And then I'm going to do comma 0. Now, in this equation, that comma 0 is telling the round function how many decimal places do we round it to. We're going to round it to 0 because we either want it to be a 0 or a 1, right? That it's not going to have a decimal component. Let's validate that and make sure it's correct. And now let me explain. So this equation now is designed where, consider if x is 0, well, then we have 0.01 divided by 0.1. And the answer to that is 0.1, which if you round it to a whole number, it rounds to 0. Now, 1, if you put a 1 in here, it's going to round to a value fairly close to 1. And really, the higher up you make that x, the closer and closer it's going to be to 1, because the x is just going to take over the numerator and the denominator. Okay, digressing a little bit, but if I now test this equation and I punch in x equals 0, it's going to happen pretty much just the way I said. We have a result of 0. Now, if we put in 1, the result's 1. Now, if I get crazy with this and I make it 1,000,000, 1. And what I also wanted to do, I wasn't certain in this case if the customer needed support for negative numbers, but I can test it with -1, and that comes out 1. And I could do -1,000,000, comes out 1. So the key here, and this actually isn't the end of it, but if you want to do an analog to binary conversion in the way that we had mentioned on the slides, you can make an equation just like this, and I can now save it, close it, and now just in the way you'd use the calculator here in LogicPak, you specify the calculation, and you take that variable x and you plug a value in. And of course, for this value, I'm going to choose, that's if I can find it. Analog value, here we go. And it is a drag and drop interface. We just drag it right over here. And now we have our equation set up. I will type now here, this is naming the result, analog to binary result. Okay, we are not done yet because the calculator, just by its nature, it makes a calculation. And this point now is an analog value. But remember, we were wanting a binary value. So what is the solution here? The solution is going to be when we're setting it up, and in this case, we're going to send the value to SCADA. We're going to go find that point. This analog to binary result is what we're calling it. We're sending it over. Now you're going to see this analog to binary result. The point type is showing, again, by default, coming from the calculator, analog, but we know that the value is either going to be 0 or 1 just by the way we set the logic up. So we can actually set the point type to binary. Now it's going to appear on the binary section of this point list. If you need to change the DNP address, you can. You can change it to a 1, let's say. But now when we go put it into the NC, or we put it into the web interface, put it on the Orion, this thing is going to behave just like a binary value that is either a 0 or a 1. With that, that's what I wanted to show you about this. If you have any detailed questions about this sort of application here, if you have any questions about scaling, a few places to look. One, we had mentioned that document that was in the docs folder. That's if you go under help and documentation, you can see the bundle of PDF documents that come with NCD. Jamie, how are we doing with the questions? Have we pretty much handled them? Are there anything I want to talk about briefly? Now we are at 10:57 Central. We will be wrapping it up in just a moment.
Yeah, I think we covered all the low-hanging fruit. There's a couple here that we might have to look into and send in our follow-up. But I think we're good on the questions we're going to answer right now.
Yep, that's no problem at all. And just as a comment from what Jamie said, if you put in a question and you didn't get an answer, we are probably looking into it. We send an email out that answers the questions that you all sent in that maybe we weren't able to address on the call. So keep a lookout for that email if you asked a question, did not get a response, because we will be answering it in that upcoming email. So I guess I'll move ahead to the conclusion. And everyone, I hope you enjoyed this webinar. I hope it was helpful to you. But I'll conclude as we always do. Again, at Novatech, support is a big deal for us. And of course, myself and the sales engineer team, support's really, it's a lot of what we do. And we will help out customers, and we'll travel. We'll get to meet some of you guys here and there. But what that means to you guys is basically we're here to help. Like we want to get to meet you, and we want to make sure all your problems are taken care of. Make sure you're not stuck with anything on the Orion. We want to help you out. So the customer community right here, if you get a membership with the customer community, it is of course free. You'll see there's a search bar. You can search for various topics if you have questions about something. This is also where we keep our archive of power hours such as this one. So you can go there, search for your topic, and find resources that'll help you learn, more visual sources in the case of the webinars. You can find that right here. We also have our support site, and on our support site, that is where you can download the NCD software. You can download updates to the Orion. Those are the distro version upgrades to the Orion. Release notes for those updates, all sorts of other things too. That is our support site. Lastly, we have a sales engineer booking screen that you can actually access from the customer community. There's a link that says book a call with an application engineer. And if you click into there, it allows you to schedule a meeting based on your schedule. You can pick a date and a time and a list of our sales engineer staff. You'll see this is our current list. So you pick the person. If you've been talking to somebody, or if you prefer to speak with a certain person, select that name from the list and pick the date and time. And of course, we'll be in touch with you on that. If it doesn't matter to you, you can just select that first. The first option is anyone, and we will find the best person to speak with you based on who's available at that time. So for some cases, that might be the best option for you. So with that said, guys, I appreciate everybody signing in. We got a pretty good response from this, at least in terms of registration. So I do hope everybody got what they were hoping to out of it. And again, we're here if you need us. Email addresses for myself and Jamie are on the screen. So with that said, we're going to call it a day here. This is the end of the webinar. And once again, thank you, and have a good rest of the day.
Thanks, everybody.